Alright, in this video we're going to answer binomial expansions tutorial sheet. Okay, so let me just show you the questions that we're going to answer. So you can see all these: Pascal triangle, alpha and beta. We need to show that, simplifying with factorial expressions, some proofs right there. Okay, and then we've got the ones that involve the negatives, the fractions, um, and then the square roots. Okay, so all these questions are going to be answered in full for you. Okay, so the numbering may be different because um, where we answered them from were numbered differently, but they are the exact same questions. Okay, so if you're somebody who is new to binomial expansions and you'd want to learn everything explained step by step, use the link in the description below to do that. Okay, let's get into it. Starting with a very basic concept of the binomial expansions, we're now going to use the Pascal triangle to expand. So I've already introduced and explained the importance of understanding the binomial expansions. Yeah. So we understand that if you're dealing with a basic multiplication of, I like using the idea of x plus y and a plus b because these are the ones that they usually use. If this is the power 2, you understand it implies you multiply x with what's in the brackets. Of course, it means you've got two brackets, okay, like that. So you can choose to get any. In my case, I've gotten that one. Get the first letter, which is x, and then the second one, again multiply it by the other side. Of course, we understand this is going to give us like x squared plus 2xy plus y squared. Now, look at the coefficients here. You've got the 1, 2, and 1. So a Pascal triangle can help us predict that when you've got the power, when you've got an expansion of the power 2, you're going to have the coefficients 1, 2, and 1. So we'll be able to actually, instead of doing this expansion or multiplication, for example, if you've got a number like 5, 6, for imagine multiplying 6 of these, how long will it take? So the triangle can help you do it faster, not as efficient as the theorem itself would be. So let me just try to write down it for you. I believe you already know it. So 1, 1, 1. So where I've written 1, 1, this is now the first expansion. So the second one, which is the power 2. So how is it coming about? So from this point now, whatever you write in between should be the addition of what is on top. In this case, addition of 1 and 1. Okay? So continue expanding as we go in the next row. So if we add the 1 there, always there will be ones at the end. Here it will be addition of 1 and 2, which of course will be a 3. Again there it is a 3. And then of course at the end you have 1. We can continue. The next one, of course, 1 at the end. This will now be 4. That will be a 6. That will be a 4. That will be a 1. That will be a 1. That will be a 5, 10, 10, 5, 1. So I said this is the first expansion. So this is the second, third, fourth, and fifth. You can actually tell by these numbers 2, 3, 4, 5. So take note of this triangle. We'll utilize it. Of course, in this case, we know we're going up to 7. So just try to expand it down. Okay, I already have it written down, so we won't have to write it again. So for the sake of the first one, we are saying it is x plus 2y raised to the power 5. Yeah? So if I bring back the triangle, that's a fifth expansion. So these are the coefficients we have: 1, 5, 10, 10, 5, 1. Okay, so these are the ones we're going to use to expand that. Now ideally, one thing that you should know is that when you are making binomial expansions, if one guy is increasing, the other one should be reducing. So let's take it this way. 1, that's the first coefficient, multiplied by, let's take x to be the maximum power. So we'll start with x raised to the power 5, and then the other one will start from to the power 0, and we'll continue like that. So ideally, this is what should be happening. So plus the next one, the next coefficient is what? 5. And then x will now be to the power 4. 2y will now be to the power 1. So you've seen one is reducing, the other one is increasing. And then 5. The next coefficient is what? 10. So 10, x to the power 3, 2y to the power 2, plus, now again we've got another 10, so we can now say 10 again. X this time around will be to the power 2, 2y this time around will be to the power 1. Wait, no, this is increasing. The 2y part powers are increasing. We start from 0, 1, 2, so it now be 3. Another coefficient that we have is now 5, x to the power 1, and then 2y now will be to the power 4, and then finally we have 1 at the end. So x will now be to the power 0, and then 2y will be to the power 5. So basically this is what happens. If you start with 5, you end with a 0. If you start with a 0, you end with 5. In short, you end with whatever is the power of n, in this case, which is like 5. So at this point, this is very easy because the work of the Pascal triangle is done. And so all you just have to do is just continue the expansions. So what we have, so this raised to the power 0 is a 1, that's a 1, so we just have x to the power 5. So people who've dealt with Pascal's triangle and binomial theorem know, understand that there is no need of indicating the first one, the first coefficient, and also the other part. You only go with the one that you're starting with the maximum power. Now this is going to be 5 times the 2y, that's going to be 10. In terms of 5 times 2 is a 10, and then I can say x to the power 4, and then 1y there, and then plus. Now 2y squared is going to give us 4y squared. 4 times 10 gives us a 40. So we've got 40x to the power 3, and then y is the power 2. Okay. At this point, 2 to the power 3. 2y to the power 3 is going to be like 8. Y to the power 3. 8 times 10, that's 80. X squared, y to the power 3. And then 2y to the power 4 is going to be like 16. Y to the power 4. 16 times 5 is 80. So we have 80x y to the power 4. And then plus the last one, which is 2y to the power 5. 2y to the power 5 is like 52. Y to the power 5. Basically, this is how you expand that. Very simple and straightforward. We can apply the same concept to the next one. So feel free now to pause the video and try out the next one. So we have a minus b raised to the power 4. How do we go about it? So the coefficients for the fourth expansion in our triangle, we had 1, 4, 6, 4, 1. Okay. So 1. Now if we're starting with a, to be a to the power 4. Of course, b, negative b would have to start from a 0. I don't have to show it. So plus a will now be, so the coefficient is 4. A will now be to the power 3. and then our negative b will now be from 0 now to power 1, where it can now appear. Next coefficient is a 6. Our a is 2 since it's reducing, and then our negative b will now be 2. Next coefficient is a 4. A will now be the power 1, and then negative b will now be the power 3. The last coefficient is a 1. So a will be the power 0. There's no need of us showing it, so we'll just have negative b to the power 4 as well, which is of course the maximum value of n. Simplifying this, we have a to the power 4. So when we have a negative b raised to the power 1, it will remain a negative, so we're going to have negative 4, a to the power 3, and the b itself. Here it's the power 2, so it will become positive b squared, so it will be 6a squared b squared, and then we have got 4. Since that is raised to the power 3 and it's a negative, it remains a negative, so negative 4 a b to the power 3. This is negative b raised to the power 4. That's an even power, it becomes a positive b to the power 4, and that is our final answer. So ideally, you've seen the many concepts here is just understanding how to come up with a triangle. Okay, whenever you understand the triangle, things become very easy and very familiar. Okay, good. We're now on the third one, which is very simple. X minus 3 power 6. So I didn't go as far as expanding the 6th term in the triangle that I wrote down, but of course if you do add an extra line, the coefficients will be 1, 6, 15, 20, 15, 6, 1. Let's do it quick. So what we have so for the first one to just be x to the power 6 multiplied by the coefficient of a 1, which makes no difference. The next part, the coefficient is a 6. The power of x will reduce by 1 to be 5, and then when I'm multiplying by negative 3 raised to the power 1, next coefficient is 15 multiplied by x to the power 4 because x powers are reducing, and then negative 3 raised to the power 2. The next coefficient is a 20, x to the power 3, negative 3 raised to the power 3, plus 15 multiplied by x to the power 2, and then negative 3 raised to the power 4, plus 6 raised to the power x, and then negative 3 raised to the power 5. Finally, we've got a 1. X will be the power 0, so no need of showing it, and then negative 3 will now be the maximum power, which is 6 itself. At this point, your work is only to simplify, okay, which shouldn't be too hard for you. So x to the power 6 that would be negative 18, x to the power 5 that would be negative 3 squared is going to be like what, 9? So 9 times 15, so 135, x to the power 4, negative 3 squared, 3 times 3 is 9, 9 times 3 is like 27, so that would be negative 27, 27 times 20, 540, so negative because 540 x to the power 3 3 times 3 times 3 times 3, 81. So that's 81 times 15, 1215. So 81 times 15 is 1215 x squared, and then 81 times another 3, 243 times 6, that gives us 1458. That's of course going to be a negative because it's raised to the power to an odd power, which is a 5. So x, and then finally 3 times 3 is 9. Of course 81 times 3, which we're from dealing with, gave us 243. Now 243 times 3, 729. So that will be a positive 729. And this is now our expansion of that term. I think at this point the other ones are not very complicated to just expand. Okay. So, but let me go on and just like try to deal with one that's a bit look a bit complicated. Okay, let me do these two. This one just implies you add an extra coefficient. So what did we have in our already? So to the coefficients that we had 1 there, so 1, 6, 15, 20, 15, 6, 1. This was a 6 expansion. The seventh would be 1 plus 7, 6 plus 15 is 21, 35, 35, 21, 7, 1. So use this one for that one. Okay, everything remains the same order, one with an increasing power, or an reducing power, and the same of course applies to this one as well. But since it's small numbers, I can quickly do it. So we have 2 minus x to the power 3. So for the fourth expansion, we had 1, 4, 6, 4, 1. So feel very free to pause the video and just try this one out. Try this one out. Try this one out. Okay, I hope you have. So for the first one, the coefficient is a 1, no need of showing it. So if I decide to start with 2 to the maximum power, which is of course 4, so 2 to the power 4 plus, we now have a 4 multiplied by 2 now to the power 3, negative x will now start to the power 1, negative x to the power 3 raised to the power 1, and then 6 2 to the power 2 now, and then our negative x to the power 3 now to the power 2 as well. Can add some more. So 4, 2 will now be the power 1, negative x to the power 3 will now be the power 3, since we're moving from 2. And then finally the last one will just be a 1. 2 will now be the power 0, so ideally we just remain with like negative x to the power 3 raised to the maximum power over 4. Remember I started with 4 of 2, so the other part will now end with maximum power. And that's where binomial expansion usually comes out. 2 to the power 3 is 8 to the power 4 is 16, so we have 16. This is 8 times 4, 32. Now don't forget about the negative power there in the brackets. So negative 32 x to the power 3. That's going to be positive x to the power 6. This is 4. That's 6. So when you multiply two powers, x to the power 3 to the power 2, you multiply the powers to give you 6. Is that what? Or in other terms, you can think of it as negative x to the power 3 times negative x to the power 3. That will give us you like a positive. So yeah, 6 times 4 is 24. Yeah, so I have like positive 24 x to the power 6. This is going to be a negative, but the power will be the power 9. 4 times 2 is like 8. Negative 8 x to the power 9. This is going to be the power positive x to the power 12. Okay, we can now do the last one, since I've skipped this one, which you can do. Okay, let me just guide you. What are the coefficients? 1, 7, 21, 35, 35, 21, 7, 1. That's the 7th expansion in our Pascal's triangle. Okay, so pause the video and just try that one out before you proceed. And if you have, let's continue. So the last one, we have 2x plus 1 over x to the power 6. So here we need a 6th expansion. So let me just check my book. So 1, 6, 15. I hope you wrote it down from the start, because that's what I've been using. I wrote it down on my paper. So you just want to practice more with a binomial, the Pascal's triangle. Okay, so at this point, the first part is 2x. So 2x raised to the maximum power, which is 6, plus, now the second coefficient is a 6. So the reason why I omit the first one and the last one is because they are ones, they don't make any difference. So it will be 6. The one we started with will now be reducing to now be the power 5. 1 over x will be the power to start from 1. The first part was that it was supposed to exist with a 0, but I didn't show it because I knew it was going to disappear. So we now have 15. 2x will now be the power 4. 1 over x will now be the power 2, plus the next coefficient is a 20. 2x to the power 3. 1 over x to the power 3. 15. The power 2x will now be the power 2. 1 over x will now be the power 4. And then we have 6. 2x to the power 1. And then 1 over x to the power 5. And finally, we just have 1 over x to the power 6. Because 2x will be the power 0. The coefficient is a 1. No need of showing those. So this is now, you have to remember I'm assuming calculators are not allowed. So 2 to the power 4, we understand it's 16. 2 to the power 5, we understand it's 32. So 2 to the power 6 is obviously going to be 64. So 64 x to the power 6. That's going to be 2 to the power, that's going to be 32. Now a 32, which you can write down and just multiply with a 6. Okay, 32, 6, 12, 1, 18. 3 times 6 is 18, plus 1, 19. So 192. 192. Yeah, 192 x to the power 5, and then x. So x to the power 5 cancels out with x to the power 1. That will give us x to the power 4. Then the next one, this will be 15. 2 to the power 4 is going to be 16, and then x to the power 4. Now don't forget you're dividing by 1 to, so if you raise 2 to the power 1 is just to be a 1, and then x to the power 2 to be x to the power 2. So the 2 will cancel with the 4 there, it will remain x to the power 2. So it remains with like 15 times 16, which you're able to multiply, 240 x squared. The next one, this is going to be 8 x to the power 3, and then that's also x to the power 3 there. So you'll cancel out because one is on top, the one is on the denominator. So you remain with now 20 times 8, which you're able to multiply. If you write down, give you 160. So 160 with no x. But so this is where I guess these are the questions where they ask you to say find the independent term, find the term independent of x, where we've got x on the other expression as part of the numerator, the other expression as a denominator. There exists an independent term, a term independent of the variable x, as you've seen. So 2 to the power 2, that's going to be a 4x squared. So 15 times 4, that's 60. Now x squared on top, x to the power 4 bottom. So on the bottom we remain with x squared. So that will be 60 x squared plus 6 times 2 is 12. X, 1x on top, 5x is on the bottom. So I have x to the power 4. And then finally 1 over x to the power 6. So that's our answer for that last part of the question. Okay? If alpha and beta are the roots of equations, so you look at this question and you ask yourself, how is it part of binomial? So I just want to show you how you can use binomial to expand expressions like this one and that one. Of course, I'll try to approach the first two without binomial, and then I'll try to show you the necessity of using binomial expansions. Alright, so given alpha and beta the roots of the equation 3x squared plus 5x and then plus 4 equal to 0. Given that's the case there, we are supposed to determine the given expression. So alpha and beta can be expressed in terms of the product, which is c over a, and then the summation, which is negative b over a. So you notice that the form of the quadratic function is actually ax squared plus bx plus c. So if you look at the given equation, which one is c? C is 4, right? So the product becomes 4. Our a is 3. Alpha plus beta, negative b, negative 5 over 3. So this is basically what we have. Before I forget, so the product, take note of the product of the beta is 4 over 3. The sum is negative 5 over 3. So we can go on and erase this. At this point, feel free to pause the video and try out the questions now. So the basic idea is you're supposed to express the given questions in the form of either the product or the summation or both. So if you look at the first one is a very common question, alpha squared plus beta squared. So there's no way you can actually substitute in that directory. So you're supposed to find the other form of the question that can help you. Alright? So let's try to see how we can do that. So we know that the shortcut The shortest way we can try to think of this is we know that there is a term that can be alpha plus beta squared, and if you expand this quadratic, it gives you understand that this means alpha plus beta multiplied by alpha plus beta. So if you actually want, you can actually use binomial even from just the start to expand this. But of course, you know that you can multiply alpha with the entire part there, it becomes alpha squared plus alpha beta. Again, if you get the beta times alpha, it will also be alpha beta. That's why this term becomes 2, comes out twice. So it becomes a 2 there, 2 alpha beta, and then of course for the third part, it is just beta squared. Cool, right? Now, what if you try to think of binomial expansions? Think of a Pascal triangle that we've looked at already. You can see that the first term is 1, 1, and then for the second expansion, it's 1 to 1. So you can see that's where these are coming from, right? So coefficient of a 1, coefficient of a 2, and coefficient of a 1. So you can equally use that for the expansion. Okay. Now you would wonder how. So if I know that 1, 2, and 1 are my expansions, or are my coefficients of expansion, so for the first term I can start with alpha, and it can start with a maximum power, which of course will be alpha squared, and then the other one will start from 0, so it will just not exist or show up there, because beta to the power 0 is just 1. And then for the second part, alpha will now reduce by 1, beta will now increase by 1, it will be beta 1. And then for the last one, the 1 I can just remove it, doesn't make any difference of course. And then I know that at this point, since alpha has been reducing, it will be alpha to the power 0, so no need of showing it, and beta will now be beta to the power 2. Of course, if you reduce this, it becomes alpha squared plus 2 alpha beta plus beta squared. So this is the role that the binomial expansions are playing in this question. Okay. But for alpha plus beta to the power 2, which is of course easy for you to look at, you can easily multiply even without binomial. But of course you will see the necessity as we proceed. Now, how do we actually answer this? Remember, our focus is we are trying to find the value of this part. Okay, so the question I can ask you right now is, can you see it on the right hand side? So we can. So we can actually group this one and that part. So alpha squared plus beta squared. Now this part is not. So we can take it on the other side, or rather add the additive inverse on both ends. So where we have alpha plus beta squared on the left hand side minus 2 alpha beta. So this one has been removed from the right hand side. So what has become the subject of the formula is actually the expression that we want to simplify, or actually evaluate the exact value of it. So we can now see that the formula we've come up with is alpha plus beta in brackets squared, and then we're subtracting the middle term. So at this point, we now know that the question that they're interested in us looking at, we've expressed it in terms of the product of alpha and beta, and then also as a summation. So we can equally we can actually simplify it very fast from this point, since we know both the product and the sum. So we can start with the summation, which is negative 5 over 3 in the brackets, raised to the power 2, minus 2 alpha beta, the product is 4 over 3. So negative 5 over 3 squared will give us 25 over 9. And then 4 times 2 is 8 over 3. At that point, you can still go on and actually simplify. Common denominator is a 9. And then you have 25. 3 into 9 is 3 times 8. 24. So 24. So with a 24 we have 25 minus 24. You end up with 1/9. So that's for the first one. We're done. Pause the video and try out the next one. So every time you want to find the exact value, what you want to do is express whatever you're given in the form of the product and also the summation. So for the second one, we have alpha over beta plus beta over alpha. So I don't know how, but let's just try to add these. Common denominator is what? What's the common denominator? So common denominator is alpha beta, and then if we try to divide by beta, which is the first one, you're going to remain with alpha multiplied by what's on the top. It will be alpha squared. Again, if you go to that part, it will be beta squared. So adequate, you can see that okay, this is actually it's related to the previous question that we had, right? So what do you think? What can be done at this point? So check the numerator. The numerator is basically what we had in the first part. So we actually express that in the form of alpha beta bracket squared minus 2 alpha beta divided by alpha beta. So at this point, the entire expression has been expressed in the form of the addition and the product of alpha and beta. So we can just substitute alpha beta squared, alpha plus beta, that's what? Negative 5 over 3. Let's not forget. Negative 5 over 3 squared minus 2 alpha beta, the product is 4 over 3 divided by alpha beta. Alpha beta is 4 over 3. So dividing by that, okay. You can now try to simplify this. So obviously on top we understand that what we found for whatever was on top, we found 1/9 if you're paying attention, because this is basically the same. For the sake of this question, it's basically the same. So you just want to get the same 1/9. If it's not given in the previous question, this is where now you just have to manually simplify this. But since we know that we got 1/9, we won't take time. 1/9 divided by 4 over 3 is as good as, so if you're dividing by 4 over 3, that's as good as multiplying by the reciprocal. I'm teaching you certain shortcuts that will not waste your time. So 1/9 multiplied by 4 over 3 is equal to the previous step. So 4 over, is it really 4? We're dividing by 4 over 3, yeah, and then multiply by the reciprocal. Wait. If the reciprocal 4 over 3 is 3 over 4. So 3 there it's 1, 3 there it's like 3. So we have 1 over like a 12. So that's it for the second part of the question. We are now at liberty of proceeding to the next one. So before you pause the video, I want you to use binomial expansions instead of using the normal expansions. I want you to use the binomial expansions to simplify that. So obviously you've gotten an idea in a case where you have alpha squared plus beta squared. We said the suggestion there was to express it, or get to express it in the form of alpha plus beta in bracket squared. Okay, so what you basically get to do is expand this part and then try to identify the existence of that expression in the expansion. Remember, it was alpha squared plus 2 alpha beta 2 alpha beta and then plus beta squared. So we identify that, oh, okay, we have it there. It is alpha squared plus beta squared. And then the term that we're not interested in can go the other side so that we can come up with a subject of a formula. So it was actually alpha plus beta squared minus 2 alpha beta. So equally, we can actually do the same for this one. So you can now pause the video and try it out. But of course, we don't want that kind of, I want you to, as you think of expansion of alpha cubed plus beta cubed, so as you think of how you can go about that, just group it in the brackets and then raise it to the third power. So now as you think of expansion of this, I want you to use binomial expansions. You can use the Pascal's triangle, the binomial theorem, whatever you can use at this point. No restriction. Okay, so what should I use? Okay, let me use the Pascal's triangle or the binomial theorem, whatever. So we have 1, 1, 1. Let me use the Pascal's triangle. For the next one, I'll use the binomial theorem. So 1, 2, 1, 1, 3, 3. I've already shown you in the previous question how you basically get to come up with this triangle. So where we are seeing the 3, this is now the third expansion. We start from this one. The first one is not an expansion. So the first one, second, and third. So these are the coefficients we're interested in: 1, 3, 3, and 1. Okay. Now we'll start with alpha to actually get the maximum power, right? So it will be alpha to the power 3. The next coefficient is a 3. Alpha will now reduce by 1, it will be like to the power 2. So beta will now start from 1. So one thing that you're not seeing is from the initial step there, I believe by now you understand that the coefficient there was a 1, alpha was the maximum power, beta was from the minimum power, so that's why it's not showing. So on the next step, we expect that beta will actually increase by 1, alpha will reduce by 1. And then we're following the first Pascal's triangle to help us with the coefficients. Okay? And then we've got 3 again. Alpha will now reduce again, it will be alpha. Beta will now increase, it will now be 2. And then we have the last part, which is of course going to be just beta to the power 3, since alpha is going to be the power 0 at that point. Remember in the previous step, it's like I want to clearly show that 2 is actually the power of beta at that point. So we expanded there using the Pascal's triangle. Now we have to actually identify the existence of alpha cubed and beta cubed. We can clearly see them there. So if we group them, we have alpha cubed plus beta cubed. Okay, so what we'll see is we are remaining with alpha plus beta, the power 3 in the brackets. So if this term goes the other side, it becomes minus 3 alpha beta, of course alpha squared, and then also minus 3 alpha beta squared equal to that. Now don't forget that these are two different terms. They are not the same. So you can actually try to factorize 1 alpha plus beta to the power 3. We can factor out 3, and then I can also see alpha is common, so is beta. For the first part, if you remove negative 3, alpha and beta, since alpha is squared, alpha will remain. And then for the next part, of course, remember if you're dividing by negative, it will become positive. 3 alpha, since beta is squared, beta will still stand out. So we've now made our interest to be the subject of the formula. We're interested in alpha cubed plus beta cubed. And if you try to check everything on the left hand side, that is the summation, that is the product, that is the summation. So we're able to simplify it. Okay? How do you do that now? just substitute. Just substitute. So alpha beta value there is negative 5 over 3 to the power 3 minus 3 alpha beta, which is like the product, 4 over 3, and then in the brackets we have alpha plus beta, which is again negative 5 over 3. That's what we have, and we believe that is equal to our question of interest, alpha cubed plus beta cubed, trying to determine the exact value. So this is now just dependent on your simplification, how you can actually go about simplifying this. Okay. So 5 times 5 is 25 times 5, that's going to be negative 125. 3 times 3 is 9 times 3, 27. That can just divide. You remain with a minus 4. Minus 4 times minus 5, that's a minus 20 over 3. If I'm not mistaken, that should be a minus. How is it a minus? Where? This is a negative, that's a negative, so it's a positive 20 over 3. Okay, I think this is something easy to simplify at this point. Common denominator is 27. That remains 125. 3 into 27 is 9. 9 times 20. 9 times 20. 9 times 0 is 0. 9 times 2 is 18. So 180. Now 180 minus 25 should be 55 over 27. So that's where you end for the third part of the question. Alright, so if you're one of the people that are enjoying this video, just wanted to let you know to say you can actually access the full solutions to this video using the link in the description below. Okay, in addition to that, you access all the topics. I simply mean all the topics in mathematics, from set theory to calculus. Okay, so use the link in the description below to learn and access all the tutorial sheet solutions. Okay, so we've got 3 sections on our site. We've got past papers, we've got tutorial sheets, and we've got learning the topics step by step. Okay, I hope you do that. Wishing you the best. Let's get back into the video. Let's try to proceed. Now I said for the last one I'll use the binomial theorem, so I want you to try it out. So we have alpha to the power 4 plus beta to the power 4. I want to express it in the form of the product and also a summation. How do we go about it? Don't think too much, try it out. Give it a shot. What have I written there? That's beta to the power 4, not alpha. So basically what happens here is something very simple and straightforward. So you know your binomial theorem. You understand that if you've got alpha or a plus x raised to the power n, the expansion becomes a to the power n plus, and then you have n a to the power n x plus n choose to a n. You now, this is n minus 1, of course, so that's n minus 2. That becomes x squared. You continue like that, and so on and so forth. So basically you are applying the same idea that we've applied previously. Okay, where you understand that one starts with a maximum power, the other one starts with a minimum power, right? So if we're going to put this in the brackets, alpha plus beta to the power 4, we understand that the first expression we can choose to start with alpha, so we'll have alpha the maximum power, and then we'll be using now the the binomial to come up with the coefficients. Everything else remains the same. So forget about the formula. The shortcut is combinations, right? So you start with, for the first expression is n0, second one it's n1, so you just be increasing the values down. So the Pascal triangle is helping us to come up with these coefficients, but we can use combinations to just help us come up with the coefficients. Okay, and then apply the other rules, the other parts. So n choose 0, in other terms, this is just going to vary to 1, this is just going to vary to n, and that's why for the first two we're able to tell 1 and n. Okay, so 1 and n are the first coefficients, and then we can proceed from n choose 2, n choose 3, and so on and so forth. Just take note of that. So for the first one, 1 makes no difference, so alpha with the maximum power, beta with the minimal power. Second is n, which is the power itself, 4. Okay, what do we know there? So it will be 4 times alpha will now reduce by 1, it will be to the power 3. Beta will now increase by 1, it will be to the power 1. The next coefficient is we don't know. So after 1 plus n, it's now n choose 2. What does that mean? It means where there is n now, in this case, our value is a 4. So let me just show you to say the next coefficient we have is 4 choose 2, 4 choose 3, and then 4 choose 4. So 4 choose 2 means, I'm trying to assume calculators are not allowed. So 4 factorial, 4 minus 2 factorial, 2 factorial. So whatever you have on top, which is the value of n, should be 4 factorial, and then subtracted 2, which is this part, factorial of the subtract of the difference, and then of course 2 factorial. So 4 factorial will just remain to be 4 times 3 times 2 factorial. So we have 2 times 1 and then 2 factorial. So that can disappear. 2 into 4 is like 2, right? Times 3 is 6. So we have a 6. Alpha will now reduce by 1 again. Beta will increase by 1. So we continue like that. 4 choose 3. 4 choose 3 is what? 4 factorial. 4 minus 3 will just be 1 factorial, and then 3 factorial. So on top we're just going to remain with a 4. So 4, and then alpha will reduce again, and then beta will increase again. Finally, we can guess the last one will give us a 1. Okay, so that will be alpha at the power 0, which we don't have to show. Beta will now be the maximum power, which is, how have we done it? So I've not done a good job. So here it was the power 1, there it was the power 2, here the power 3, and now the power 4. Okay, that's fine. Hopefully I haven't confused you using the binomial theorem, but basically the idea is, what we're trying to say is, just use the binomial theorem in the normal way. So you start with, like, in this case we've got a power of 4, so it will be 4, 0, and then alpha at the maximum power, beta to the minimal power. So you continue expanding like that. This is basically the main idea there. Alpha will be reducing, beta will be increasing, until you get to the last part. So assuming you've gotten that part and you've understood how to go about everything, so at this point now let's just like conclude by making that the subject. So if you try to observe, where are they? So that is alpha to the power 4, beta to the power 4. everything else can be on the left. So we have alpha plus beta to the power 4. So I'll be subtracting everything else. Let's try to identify them. This part, 4 alpha cubed beta minus 6 alpha squared beta squared, and then minus 4 alpha beta cubed. So I've removed all the other 3 terms, and then everything else remains on there as our interest, which is of course this part. So this is now equal to that. So how do you go about it now, simplifying? So simplifying at this point will just require you to just like substitute into the given parts. But of course, we want to be sure, is this already in the form of just a product and summation, or we've got some differences? What do you think? So the first part is already expressed as the sum. This part can equally be expressed as, you can group the two, just the same power 2, and then you can separate the others. But of course we can still go on and combine these 3. We've got a common factor. So I think 4, 6, and 4 can have a common factor of like a 2. So you can say alpha plus beta to the power 4. If we pull out the minus 2, I can see alpha is common, or I can decide to do something different and unique, but let me just go by the same way. So group out a 2, and then I can see alpha is common, and then I can see beta is also equally common. So what is limiting my highest power I'm picking? Beta there is only 1, there alpha is also just 1. So that's why I'm restricted. So if I want, I can ignore this part. Let's ignore it and only focus on these 2. So if we do that, that would imply we're going to have a minus 4 instead, factored out, and then alpha and beta. So for the first part, since it's alpha cubed, if we remove a single alpha, it will remain with a positive alpha 2. Then for the last part, we'll remain with beta squared. Okay. And then minus the 6 alpha beta, which can just be grouped together in brackets, and then raise the power 2. At this point, we are sure of what we can do. But you can see there's something interesting there. To simplify that, remember it's alpha beta squared minus 2 alpha beta. So just plug in the values here. Alpha beta is negative 5 over 3 to the power 4, and then alpha by beta is 4 over 3. For the brackets, alpha plus beta, again it's negative 5 over 3 squared, so I can just put that in brackets, and then minus 2 alpha beta, which is like 4 over 3. Okay, and then minus the last part, 6 alpha beta. So a lot of space here. So minus 6 alpha beta, which is like 4 over 3. Now it is squared. So just simplify this and see what it gives you. Let's have the answer commented. So my area of interest was just trying to use binomial expansion to expand that, not really to find the value. So you can find the value by just performing simple manipulations of the values. Okay, hopefully my calculations on my paper are right. should get something closer to negative 1501 over 108. Okay, so this is where we end for question 8. So we're now on question 9. If alpha and beta are the roots of the quadratic equation 5x squared minus 5x minus 1, find the quadratic equation with integral coefficients which have the roots. Part 1 and part 2 have been given to us. Okay, so the equation we have is 5 x squared minus 3x minus 1. Okay, so we can quickly determine the product alpha and beta, which we understand is given as c over a. Our c in this case is negative 1, our a is 5, and then the summation of alpha and beta, which is of course negative b over a, negative of b, so our b in this case is negative 3, our a is 5. So we have negative 1 over 5, and for alpha plus beta that becomes positive 3 over 5. Okay, so I want you to take note of these two values, 3 over 5. So alpha beta is negative 1 over 5, and then alpha plus beta is 3 over 5. Take note of those two values. So now how do we find the quadratic equations of a given coefficients? So I'll start with the first one. So we have 1 over alpha squared, 1 over alpha squared, and then also 1 over beta squared. So we're supposed to find the addition and the multiplication. So I'll start with addition. So quickly the common denominator becomes alpha squared beta squared, and then we're going to have beta squared plus alpha squared. So previously, the previous question has already taught us to say alpha squared plus beta squared can be expressed as alpha plus beta squared minus the product minus 2 of the product, 2 alpha beta. Now the denominator that we have is alpha squared plus beta multiplied by beta squared can be grouped together as alpha beta and pour out the square root. The idea is one to have it in the form of alpha multiplied by beta and alpha plus beta. At this point we've done just that, and we are ready to just substitute. Okay, so alpha plus beta is 3 over 5, so 3 over 5 squared. Let me just write this on top properly. Or I can just do this. So alpha plus beta is 3 over 5, so that's squared, minus 2 alpha beta. Alpha beta is negative 1 over 5. Now we're dividing that by alpha beta squared, which is negative 1 over 5 squared. Three over 5 squared is 9 over 25, plus that's 2 over 5. Now all this is being divided by 1 over 5 squared, which is as good as 1 over 25 as a positive value. Okay, so we can do it fast, we can do it quick from this point. The other way you can actually do this faster is instead of dividing, you can multiply by a reciprocal. The reciprocal is 25 over 1. So if you multiply the first one by 25 over 1, you're going to remain with just a 9. The second one, 5 into 25 is going to be 5 times 2, 10, and the answer gives us 19. Okay, so the addition is equal to 19. And then the product 1 over alpha squared multiplied by 1 over beta squared. This is going to be equal to that's going to be 1 over alpha squared beta squared, which we can express as 1 over alpha beta in brackets squared. Alpha beta as a product is negative 1 over 5, so if you square that it becomes 1 over 25. And then since it's 1 over something, or 1 over a fraction, is as good as a reciprocal, so a reciprocal of 1 over 25 is 25. So there we go. So we have a 25. Now I want you to pay attention here. Addition is associated with negative b over a. Multiplication is associated with c over a. So you have to ensure that the coefficients of the denominator should be the same for you to ensure the denominators are the same, since a is common. So 1, 1. So in this case a becomes 1, and then b, negative b being equal to 19, b will become what? B becomes negative 19, and then c is just 25. I've just equated whatever we have with what is on the right hand side. So considering the form of the basic equation of a quadratic function, I believe we know it's ax squared plus bx plus c. A is 1, so x squared, bx negative 19, negative 19x plus c, which is 25. So that's a quadratic function. Alright, so feel free to pause the video and try out the second one. So equally, we'll start with the product or addition. I'll start with addition. Alpha squared over beta plus beta squared over alpha. So the product of the two is alpha beta. That's a common denominator. And then if you divide by the beta, there you end up with alpha. If you multiply, you get alpha cubed, again beta cubed. Now this is not new to you. We've already looked at how we can expand this using the binomial theorem. So assume you just have alpha plus beta in brackets cubed. You can apply the binomial theorem in this form: 3 choose 0, take alpha to have maximum power 3, beta to have power 0, and then you continue expanding like that. So alpha now to the power 2, beta now to the power 1, and then 3 choose 2, alpha becomes the power 1, beta to the power 2, and then finally 3 choose 3. That will now give you alpha. Alpha will disappear to the power 0, and then now will just be beta to the power 3. So of course some of these is very simple for you to simplify. You understand when you say 3 choose 0, that is just equal to 1. 3 choose 1 is just equal to a 3. 3 choose 2 is just also equal to a 3. 3 choose 3 is just equal to 1. So you end up with something like alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus beta cubed. You can use the Pascal triangle. This is a very simple expansion. Let me leave what's on the left and just... So now when you look at the expansion that we've come up with, we want to ensure that we actually remain with only alpha cubed plus, since that is our interest, alpha cubed and beta cubed. Then whatever remains goes the other side, so our 3 minus 3 alpha squared beta minus 3 alpha beta squared. This is equal to the addition of alpha cubed and beta cubed. That's what we have there at that point, right? So at this point now, you want to make sure you express everything in the form of alpha plus beta, alpha multiplied by beta. So you can factor out something here. If you factor out the 3, let's see, this will drop this, alpha beta cubed. If you factor out the 3, alpha is also common, beta is also common. For the first part, you remain with just alpha. The other part, you remain with only beta. So at this point, we are now at liberty of just simplifying this, but just plugging in the values. So alpha beta is 3 over 5 cubed minus 3 alpha beta again. Alpha multiplied by beta is negative 1 over 5. In the brackets, we have alpha plus beta, which is 3 over 5. So that is going to substitute whatever we have on top there. Remember, whatever we are simplifying here is equal to alpha cubed plus beta cubed. So if you try to simplify, 3 over 5 cubed, 3 times 3, 9 times 3, 27, over 5 times 5 is 25 times 5, 125, and then minus negative times negative gives us positive. 3 times 1 is 3 times 3, 9, and then over 5 times 5, 25. So this is what is the top part. So now don't forget we're supposed to divide by that alpha beta. So I already showed you that dividing alpha beta is negative 1 over 5, so it's as good as multiplying by the reciprocal, which is going to be negative 5 over 1. Okay, so that can make our work a bit easier. If you multiply the 125 by divide by 5, 5 into 12 is 2, carry 2, so 25, that's like 5. 5 into 25 is 5, so you have 27 over 25 plus 9 over 5. So remember we're multiplying by the negative, so everything here is supposed to now end up a negative. So we just end up adding there. So common denominator 25 divided by 25, that's a 1, so negative 27. Divided by 5 is 5 times 9, 45. 45 minus 27, or we're adding, actually maintaining the sign. 45 plus 27 is 72, so negative 72 over 25. Okay. So that's our addition. And then we can now look at our multiplication. So I would want to bring that a bit closer. Negative 72 over 25. Now our product, alpha squared over beta multiplied by beta squared over alpha, that becomes alpha squared beta squared over alpha beta. Now the top part can be grouped together to just be alpha beta squared over alpha beta. You can just divide that so that it simplifies to, so you know that alpha beta is coming twice, so you can divide on top so that you just remain with 1 for the sake of simplification. So in remain with alpha beta we understand it's equal to what? Negative 1 over what? Negative 1 over 5. Okay. So now compare these two. We said the addition is equal to c over, no, the addition is equal to negative b over a, and then the product is equal to c over a. So I said we have to ensure that values of a should be the same. Yes. So if you check one here, one is 25, the other one is 5. So which one is easier to change? Is it the 5 or the 25? So the 5 is easier to change. How about multiplying by 5 both the numerator and the denominator? So we can multiply here 5, 5, so that we can have 25, because a is supposed to be common. So this becomes negative 5 over 25 being equal to c over a. So a now becomes common with one equal value. So therefore a is equal to 25. B, negative b is equal to negative 72 becomes b is equal to 72, and then c is equal to negative 5. So we can now come up with an equation at this point. So our equation therefore is ax squared, so our a is 25, x squared minus bx, our b is positive 72x, then our c is negative 5. So that is our equation there. Okay, so that's how you go about that kind of a question, and that's where this question ends. Alright, let's now proceed and look at other questions involving binomial expansions. Alright, let's look at the binomial questions now, continuing from like 10 all the way up to somewhere 21. So write down the expansion of 2 plus x squared in ascending powers of x, taking the first three terms of expansion. Put x is equal to 0.001, find the value of... So that was supposed to be the power 2, I believe, because why should they ask us to find the power 5 when they've asked us to expand the power 2? Anyway, let's just under this. So we've got 2 plus x raised to the power 2. So expansion is simple and straightforward. For the sake of introducing into the coefficients, I would just say 2, choose 0, and then our a in this case is 2 itself. So 2 should be raised to the maximum power, which is 2, which is the power of n. And then x should be the minimum power 0. The second term will be 2, 1, and then 2 will now reduce. So 1 reduces, the other one increases. So that will be the power 1, and then x will be the power 1 as well, since it is increasing from 0. And then finally we have 2, choose 2, and then we have 2 raised to the power 0, and then x to the power 2. So if you're seeing, if you've paid attention or make an observation here, you see that taking that to be my a, I've started it with the maximum power, and then it's been reducing all the way up to 0. Equally, the other one, which is x, has started from 0, 1, 2. So 1 reduces, the other one decreases, and that's the way you just arrange it. Now for the coefficients, there are a few things that you'd have to take note of that you learn from. So what it means when you have 2 choose 0, it implies 2 factorial over 2 minus the 0 itself on the bottom, and then of course 0 factorial. So 2 factorial means 2 times 1. Okay, I don't necessarily have to expand it every time because you may have big numbers. And then 2 minus 0 means 2 factorial, and then we've got a 0 factorial. So 0 factorial, for your own information, you should learn that it's equal to a 1. So if you divide 2 factorial by 2 factorial, you end up with a 1. So basically, what are we trying to say? So always you should know that in the binomial theorem, there is no need of you always showing the first part, because any number choose 0, the answer just remains 1 every time. So, and then you know that the other part, which starts with being raised to the power 0, is also equivalent to 1 every time. So with that understanding, if I was to be answering this question in an exam, I wouldn't show all what I've shown. I would just go direct to 2 to the power 2 and go to the second part. And then for the second part, 2 choose 1 is the same as 2 factorial, 2 minus 1 factorial, and then 1 factorial. So here what you see is you end up with 1 factorial on the bottom, So you just end up with 1 on the bottom. In short, you remain with 2 as an answer. Okay, so whenever you are going to have any number, let's say 4 choose 1, it would imply 4 factorial, 4 minus 1 factorial, 1 factorial. So every time whatever you have on top remains as the result. So n choose any one value, any one, it's actually always going to be n. So 2 choose 1 is 2, so equal, I would just say 2, and then 2 to the power 1 is 2, and then x. Then 2 choose 2, whenever you have this as well, any number that you're going to have 8 choose 2 or 8 combination 8, it's basically 1 as well. And then so you don't have to show it every time, and then you know that whatever term you're having, raised to the power 0 is a 1, so you just go direct to x squared. So we have 4 plus 4x. I just took time so that you could just get some basics from the start. That is basically our expansion. Now we said in ascending powers of x, so meaning that we are right. So we have 4 plus 4x plus x squared. That's our expansion. So if you're new to binomial theorem and you want a better introduction, check the description for the video talking about that. Alright, so I'll apply an approach where I assume you've already learned the basics about binomial theorem. So let's now plug in. Given that x is equal to that value, take the first 3 terms of expansion, and then of course put x is equal to 0. So usually this makes more sense when you've got fractions and negatives, but in this case a positive number. Alright, so let's plug in. So we have 4. Where is x, we're now going to put 0.001 plus 0.001 squared. So you have 4, and then 4 times that would just be 0.00, where there's a 1 would now be 4. Now 0.01 to the power 2, how many zeros do we have? We've got 3, so it will now become 6. 1. So the question is telling us to say correct to 3 decimal places. So we just have 4.004. These are already 3 decimal places. If you add these numbers, add that one, 0.004, 4. 3 decimal places is ending at this point. So it will just be this value. Okay. We can go to 11. 11 says if n plus 1 factorial, is equal to 5n factorial, solve for the value of n. How do you go about this? So I will actually use a simple method. Whenever we've got 9 factorial or any number factorial, it means you move from that number, you start decreasing by multiplying until you get to 1. That's what factorial implies. So even when you've got letters, you can be reducing. So if you've got n plus 1, if n plus 1 is the biggest number, the next number would be n plus 1 minus a 1. So if you reduce a 1, or if you remove a 1, it will just remain n factorial. I can continue reducing it. It can be n plus 1. Sorry. n plus 1 is the maximum. The next one would be n. The next one would be n minus 1, n minus 2. So you can see that we're reducing 1 by 1 by 1 by 1 by 1. But in this case, I just want to derive to end on n factorial because I can see n factorial is equally on the other side. So you can divide by n factorial both sides, or multiply by 1 over n factorial both sides. So you end up with just n plus 1 being equal to 5. Your n value becomes 5 minus 1, which is going to be 4. And for sure, you can actually try to prove that. Try to substitute. If you say 4 plus 1, factorial, and then you say 5n factorial, 4 factorial. 4 plus 1 is 5 factorial. Now 5 times 4 factorial can be combined together to give you 5 factorial. I hope that makes sense. Or even if I decide to leave it the way it is, 5 factorial can be expanded to be, I can remove 5 and then I say multiply by 4 factorial. So these are equal. So we found the value of n without any challenges there. Okay, let's move. Look at question 12. This is now where we're trying to talk about also the same idea of simplifying. Feel free to pause the video and just try to give yourself a bit of some confidence. See if you're able to answer these two questions without any challenges. Okay, if I go to 12, we have 2n plus 2 factorial divided by 2n factorial. So the same concept to apply. Try to reduce the one that is on top up until it reaches to just 2n factorial. So 2n plus 2. If reduced by 1, it becomes what? 2n plus 1. If reduced by 1 again, the 1 disappears, it just becomes 2n factorial. Divided by the bottom, we have 2n factorial. So I want to actually show the brackets. I would want to show the brackets there so that we can clearly show that the factorial is applying to 2n and not just n. Okay, so you can see this can divide. And you've simplified. Alright, so if you're one of the people that are enjoying this video, just wanted to let you know to say you can actually access the full solutions to this video using the link in the description below. Okay, in addition to that, you access all the topics. I simply mean all the topics in mathematics, from set theory to calculus. Okay, so use the link in the description below to learn and access all the tutorial sheet solutions. Okay, so we've got 3 sections on our side. We've got past papers, we've got tutorial sheets, and we've got learning and the topics step by step. Okay, I hope you do that. Wishing you all the best. Let's get back into the video. 2n plus 2, 2n plus 1. If you want, you can go beyond and just multiply this, but I think the idea is I want to see you do away with the factorial there. Okay, pause the video and try out the other one. Alright, hoping you've tried it out. We have n plus 1 n plus 1 factorial over n minus 1 factorial. So equally here would want to reduce the top part since it's the one that looks higher. So we have n plus 1. Reduced by 1, it becomes n. Reduced by 1, it becomes n minus 1 factorial. I'll just end there. So that already cancels out or divides. And then you just remain with like n multiplied by n plus 1. You can just end there, but this is easy to multiply anyway. So it just becomes n squared plus n. Very, very simple. So this is just helping us trying to understand the factorial expressions that we use under binomial theorem, so that it will be easy as we get to approach more complicated questions ahead of us. Okay. Look at question 14. Again, still focusing on the binomial coefficients. So let's try to break it down. We see what we have here. All right. So the first part is asking us to simplify 4 choose 2 or 4 combination 2. So that's 14. And then that will be 4 choose 2. So 4 choose 2 means 4 factorial over 4 minus 2 factorial 2 factorial. So that gives us 4 factorial on top. 4 minus 2, it becomes 2 factorial multiplied by 2 factorial. So I can reduce the 4 factorial to somewhere 2 factorial so that I can just like cancel out. So 4 times 3, and then I can end at 2 factorial. 2 factorial can divide. Of course, 2 factorial is the same as 2 times 1, which is just like a 2. So 4 divided by 2 just becomes a 2. So for the first part, the answer there is a 2. Is it a 2? No, there's a 3 there. So let me do the calculations properly there. So what we have is we have 4 factorial. So 4 times 3, and then we remain with 2 factorial divided by 2 factorial, 2 factorial. 2 factorial basically gets to divide, and then you have 4 times 3, or this 2 factorial is same as 2. Into 4 it's 2 times 3 gives us a 6. So that is equal to 6 there. And then if we move to the second one, that's 8 choose 5. 8 choose 5 implies you have 8 factorial over 8 minus 5 factorial 5 factorial. So that is the same as, we can reduce all the way up to 5, since 5 is like the highest power we have. So we can say 8 times 7 times 6, and then we end at 5 factorial. 8 minus 5 is 3 factorial, 5 factorial, 5 divides 3 factorial is the same as, so for you, you go on the next step, 3 times 2 times 1. 3 there is 1, 3 there is 2, 2 there is 1, 2 there is 4. 4 times 7 is 28 times 2, 56. I'm ready for explaining to say, when you are going to have 12 combination 1 or any number combination 1, the result is just the number itself. So obviously the answer is 12. So 12 factorial over 12 minus 1 factorial, and then 1 factorial. So we just have 12 factorial, 12 times 11 factorial, because I know on the denominator if subtract 12 minus 1 is 11. It's 11. So we end up with just 12 itself. And then for the last one, on that question, we have n, choose n minus 1. So that's the same as n factorial over n on top minus what's on the denominator, which, or minus the r value, n minus 1 factorial, and then the same r n minus 1 factorial. So don't forget our formula. The formula is, if you're going to have n choose r, it's n factorial divided by the subtraction factorial and then r factorial again. So n factorial can be reduced all the way up to even n minus 1. But let's first of all try to see what happens here. So n minus 1, so far that's where we've reduced it to. Subtract now, n minus n is 0. The negative times negatives gives us a positive. Okay? Because what are we doing here? What we're doing is n minus n plus 1 is what we are remaining within the brackets. And then we have like n minus 1 factorial. This is a 0. That's a 1 factor. 1 factor is just a 1. This can divide with what's on top. The value remains to be n. In other terms, what are we trying to say? What we're trying to say is if you're going to have 8 choose 7, we expect the answer to be equal to 8. If you're going to have any value on top and then the error value is 1 less than that value, it's going to be the value itself. That's why it's n. Okay, I hope that makes sense. Show that n choose n. So I've already shown all this. So you can say we're trying to show that they're all equal to 1. N choose n, that means n factorial over n minus n factorial, and then the value of r is n factorial. So we have n factorial on top, n minus n is 0 factorial, and then this is n factorial. That can divide, end up with 1 over 1, which is just equal to 1, because 0 factorial is equal to 1. N choose 0 as well. You have n factorial divided by n minus 0 factorial, and then 0 factorial. So you end up with n factorial on top divided by n factorial coming from the brackets. 0 factorial is just a 1. That also equally becomes a 1. So we've shown by the binomial coefficients. Now for the last question on this page, which is question 16, we are told to write down the binomial expansion of 3x minus 5y to the power 7. So I've already shown you how to go about the binomial expansion. Okay, so for the first part, I already told you to say if you decide to start with 3x, it implies it's going to be the highest power 7 plus the second term will be obviously 7 choose a 1. So 7 and a 1, that implies we're just going to remain with like 7. And then 7 and then multiply by 3x. 3x the power will now be reduced by 1 to be the power 6. And then the other part, negative 5y, will now start from 1. Since the first part, why it's not appearing is because it was the power 0. Now on the third part, we can now start showing. We have 7 choose 2, and then 3x raised to the power 5, negative 5y raised to the power 2. So the 3x will continue reducing, the negative 5y will continue increasing until we get to the last part. So at this point, we can now have 7 choose 3, 3x to the power 4, negative 5y to the power 3. 7 choose 4, 3x to the power 3, negative 5y to the power 4. 7 choose 5, 3x to the power 2, negative 5y to the power 5. And then 7 choose 6, 3x to the power 1, negative 5y to the power 6. And then finally we'll just add the last part, which is of course going to be negative 5y raised to the power, the maximum power 7. So of course others want to go by the formula, but I see sometimes it's not necessary because you understand the reduction. Whatever term we are dealing with, n choose r, the expansion is a raised to the power n minus r, and then b raised to the power r. That's why you see that the negative 5y is matching up with the value that we have of r at every point. And then this other power is like a difference between the maximum power 7 minus the current value of r. This is how you go about the binomial expansions. Okay, so I'll leave the work of simplifying to you. Okay, yes, I'll leave the work of simplifying to you. I've already shown you how to simplify the coefficients, and I've already shown you how to simplify the other parts as well. Okay, so that's how you can basically go or simplify this, and it's a bit cumbersome in this case where calculators are not allowed. So I think leaving it at this point, you can just simplify it better than we have, so that things get to go better. Yeah. How? I can take a step, 3x to the power 7. At least I know 7 times 5 is negative 35 y. And then I can leave 3x to the power 6 in the brackets. And then 7 choose 2, I can simplify that. Okay? At least I know negative 5y squared is 25 y squared. I can decide to leave 3x to the power 5 in the brackets. And then until our end gets to the end, at least 7 choose 6, we understand that's just going to be 7 itself. So that point you can also simplify. 7 times the 3 there just gives you a 21. So you have like 21 multiplied by 21 what? 21x multiplied by negative 5y to the power 6. And then the last part, of course, is negative 5y to the power 7. At least, so this is basically how you can basically expand, write down the expansion of, do a binomial expansions. Of course, where calculators are available, things are very simple and faster in terms of simplifying. Yeah, but what your lecturers are looking for is they want you to understand. They want to see if you've understood how the binomial theorem proceeds in terms of simplifications. Okay. Alright, so question 17 says write down the terms indicated in the binomial expansions of the following and simplify your answers. So, of course, the way they are written, if you try to pay attention, they are written in a form that you'd have to do a bit of some calculations for you to predict the term to contain x to the power 5. But of course, I don't have to confuse you or waste a lot of your time. Whether you reverse it, I think reversing is better. So just do that. For the first one, of course, we're very familiar with simple questions where they ask you to find the nth term. Let's say 6th term. We understand our formula that we use is n choose r. And then, of course, r we start counting from 0. So the 6th term is obviously going to be where r is equal to 5. So our a will be raised to the power of the difference between n and r, and then x will be just like the value of r. So that way you see that it's actually faster and easier if you put x, because x is matching up with r if it's on the second part of expansion. Okay, so even if we leave it the way it is, let's take it x plus 2 raised to the power 8. So what we're going to do is we'll do a bit of tricky work, but I know some of you may get confused, so I'll just start with the coefficient or the constant. 2 plus x raised to the power 8. So the 8 choose r, which is matching up with the power of x, so 5. And then a is 2, so 2 to the power n minus r. 8 minus 5 is 3. And then multiply by x to the power r, x to the power 5. So this is definitely the term. Okay, so 8 choose 5 multiplied by 2 to the power 3 is 8, x to the power 5. So I've really labored to explain the coefficients for you. So I believe at this point you're very confident enough to simplify beyond that point. In cases where you've run out of time, leave it there, it's okay. But if you've got time, simplify to a point where you can just see the number. 8 choose 5 is very easy to simplify. Okay. So apply the same concept to answer these other questions. Pause the video and try them out. So if I start with negative 2 plus 3u raised to the power 5. And then n choose r. N is what? 5. R, in this case, 1 to the power of 3 on u. So choose negative 2 raised to the power 5 minus 3, which is a 2, and then 3u raised to the power 3. This one I can even simplify. I don't have, it's not like it's going to, so 5 factorial, 5 minus 3 in the brackets, factorial, and then 3 factorial. Negative 2 squared is 4. 3 to the power 3 is 27. Because 3 times 3 is 9, times 3 is 27, u to the power 3. 5 factorial can be simplified to just remain 5 by 4. On the denominator you remain with 2 factorial, 3 factorial, and then multiply by 4, multiply by 27, multiply by u to the power 3. Now 3 factorial can be expanded to make things simpler here. 2 factorial to start with is 2 times 1. 3 factorial is 3 times 2 times 1. 3 there is 1, 3 there is 9. 2 there it's 1, 2 there it's 2. 2 there it's 1, 2 there it's 2. 2 times 5, 10, times 2, 20. Now 20 times 9 is 180. Is it? I hope my calculations are okay there. 3 into 27 is 9. 9 times 2 is 18. 18 times 10 is 180. If my simplifications are okay, this should reduce to 180. And then that's now u to the power 3. Okay. Try out the last one. Negative half plus 2t. The power is 7. Oh, the power is 12. So n is 12. Choose 7. Negative half will be raised to the power 12 minus 7 is what? 5. And then multiply by 2t raised to the power 7. 12 choose 7. Negative half to the power 5 remains the negative. 1. 2 to the power 5 is 32. And then 2t to the power 7. 2 to the power 5 is 32. To the power 6 64. 128. T to the power 7. Now 32 in 64 is 2 times. In 128 it's 4 times. So we can just end up with a negative 4, 12, choose 7, t to the power 7. I think I can just end it. I can leave it there. Negative 4, choose 12 out of 5. No, 12, choose 7. Yeah, that's fine. Okay, so that's it. You can simplify it beyond that point. I'll leave that to you. But this is basically how you basically get to determine the terms indicated. And for some of you want to break or think more, this is basically just one and the same. I can go back to the first one. If you want to expand it as it is given there, you can, since you know that x is going to be reducing, you ask yourself, at what term after reducing will it be x to the power 5? So it's obviously going to be, since you start with, you're going to start with like 8, so 8, 7, 6, 5. So it will be on the fourth term where r is equal to 3, since you start from 0. It's 0, 1, 2, and 3. So that would mean that you're going to have 8 choose 3, and then x to the power 5, 2 to the power 3. Basically, if you simplify this, it's basically going to give you the same result that we found in the first place. Okay. Now let's look at the question 18 and 19. So question 18 and 19 are focusing on showing that these are equal to that. The left is equal to the right hand side. So let's start with 18 and choose. So these ones are not as easy. In fact, they're not as hard as they look. They're too simple. So n choose r is equal to n minus r. So these basically are coefficients. Okay. So I'll start with the left hand side. Left hand side for 18. The left hand side is equal to nr. nr means n factorial subtract by r and then r factorial. That's what it means. Nothing more, nothing less. We can go to the right hand side. The right hand side there means n factorial over n. Now we're subtracting the n minus r. N minus r factorial and then again n minus r factorial. Okay, so remember this is like the formula. So where there is r, now we've got n minus r for the right hand side. So we've got n factorial on top. Now if you subtract this in the brackets, n minus n is just 0. Now let's first of all distribute the negative there. So we're going to have n minus n plus r in the brackets. We've got factorial, and then we've got n minus r factorial as well. If we get to simplify that, we remain with n factorial on top. Denominator n minus n is 0. So we remain with r in the brackets, so that will be r factorial, and then we've got n minus r factorial. Now some of you can see that now this is just one and the same. All we just have to do is now reverse what we have on the bottom. So we've got n factorial. So I can now start with the n minus r factorial and then r factorial. So you can see that the left and the right hand side are one and the same. So since left hand side is equal to the right hand side, ends shown. Okay, that's how easy it is. They actually look more complicated, but when you actually get to solve them or simplify them, they are way easier. Now, at this point, you now have the confidence to try out the next question, which is question 19, right? Alright, so if you're one of the people that are enjoying this video, just wanted to let you know to say you can actually access the full solutions to this video using the link in the description below. Okay, in addition to that, you access all the topics. I simply mean all the topics in mathematics, from set theory to calculus. Okay, so use the link in the description below to learn and access all the tutorial sheet solutions. Okay, so we've got 3 sections on our site. We've got past papers, we've got tutorial sheets, and we've got learning the topics step by step. Okay, I hope you do that. Wishing you the best.